Hi there and welcome to Catchment of Resources. In this video, we are going to be looking at a simplified way to analyze piping and pipeline for any industrial sector. So in this case, we are considering 7 major industrial sectors. Someone is a manager and is sent into any of these industries, and you're supposed to consider the kind of pipe, the standards, and the likes. What are you going to do? So this flowchart is a way that can help someone to easily understand and be able to make a contribution in those sectors. So in order to select a pipe, for example, there's a difference between piping and pipeline. A piping could be like a local area network when you have a network within a building. So it's short distance within processing units or different units, you have the piping. But pipeline has to do sort of like, it's like a wide area network. When you have your system running from one geographical location to another location, that's when you talk of a pipeline. So piping and pipeline are two distinct terms that we need to understand. So in order to select a pipe, first of all, there needs to be a problem. There needs to be identified an issue to solve. So there has to be initiation. Then we need to understand the fluid type or the industry. So the industry will tell us the fluid types, and the fluid types can also tell us the kind of industry we are dealing with. From there, we move on to corrosivity. You need to identify the corrosivity of the environment, both the environment within the piping or pipeline or outside of these pipes. You need to understand the environment, the corrosivity of the environment. From there, you need to know the temperature of this fluid or the ambient temperature. In most cases, the temperature of the fluid is the determining factor. In other cases, the external could also be because you could have maximum and minimum temperature. Then you need to consider the pressure requirements, the cost, then finally you are able to select a pipe. So in the case of cost, there are times when you can actually select an inferior material, but then you retrofit it to a higher grade material to meet the properties of your medium and your fluid. But it will be more cost effective than if you use a higher grade of pipe. So first of all, you need to have your request or problem statement. Then if you are talking of, you found out that, okay, the industry is oil and gas industry or the power plant industry, these are the different codes of practice that someone needs to understand in order to have a full grasp of what is required for both the design and the construction and whatever regulation. So these are the codes and standards that are required. So you can see piping systems different from pipelines, gas transmission, because some of these codes, some of them just talk about crude oil and certain petroleum products. Other pipelines are discussing gas. So it depends on the kind of pipe and fluid of interest that determines which code is to be used. So for power plants, most times probably are talking of steam or other kinds of fluids in power plants. So there are also governing codes. Some of them are listed here as well. So we say we are in the food and drinks industry, drinks and beverage. We are talking of ASME codes, ASME BPE codes, bioprocessing equipment. We are talking of sanitary standards, and there are other standards that have to do with food and plastics to know the level of hygiene that are required. Also, food processing industry also have their own code as well. From there, you have the chemical processing industry. So chemical processing industry may be working with ammonia and some other caustic chemicals, in which case you need high level kinds of, you experience high level corrosivity in the mediums. So lastly, you have the water treatment industry as well as HVAC piping systems. So these are the codes of practice that are governing in these industries. So once you have identified the different codes of practice, you know the industry, so you have isolated yourself to one unknown out of 7. Then you can then establish the corrosivity of both the internal and the external medium. You then know what is going to govern in terms of selection of the pipe material. Because once you have established that, okay, this is the corrosivity level, you know the kind of pipes we are looking at. Then once you also establish the temperature and the pressure, you know that if the temperature is probably more than 600 degrees Celsius, you cannot use a plastic pipe or a HDP or a PEX kind of piping, you need to go for a metal pipe. So all of these are guides. So once you have identified the corrosivity, established those factors as well as the temperature and pressure, you can then use the corrosivity to identify what it is on the scale. So whether it is high pH, high corrosivity, medium corrosivity, or low corrosivity. So low corrosivity is within the pH range of 6 to 8 on the scale. According to National Association for Corrosion Engineers, their own for low corrosivity, you are talking of pure water and demineralized water. Then when you are talking of medium corrosivity, you are talking of pH between 3 to 6 as well as 8 to 11. According to NACE standards, they say seawater, brackish water, industrial cooling water. Then for high corrosivity, we are talking of less than the pH of 3 or greater than the pH of 11. So you have acidic gases, processed fluids in refineries, strong acids, strong alkalis. There are some other fluids that are not listed here, but the pH values is a guide as to what corrosivity the fluid or the environment falls within. Also, these are extremes. For example, there are some pipes that can handle some pipe materials that can handle the extreme of corrosivity. But what you need, probably you need a medium to high level of corrosivity resistance. In which case, probably the acid or the alkali is at a low level, but it is present. So that's when selection of different materials and retrofitting them to meet the required properties come into play. Once it has been established the level of corrosivity of the internal and external mediums, this is a visualization of different materials and their corrosion resistance. The highest level of corrosion resistance for all these resilient materials that are used in industry are the nickel alloy metals, which is Hastelloy and Inconel, for example. They have the highest level of corrosion resistance, followed by stainless steel. Within stainless steel, you also have duplex steel. Aside that, we then have the HDPs, the PEX, the PVC, then the low alloy steel and carbon steel. So carbon steel is the lowest among the common pipes used in this industry. So in terms of high temperature and high temperature capacity, certain materials can be used. For example, Hastelloy and Inconel have the highest temperature. It could be higher than this, but this is just a minimum threshold in the range of those materials. And the plastic materials have lower high temperature capacity. Furthermore, there are cases where certain metals can be used and then it is retrofitted within. So a different kind of material is retrofitted within this material in order to achieve some certain properties of the pipes. So you are leveraging the properties of one pipe which is so expensive, using less of a material of it on another pipe in order to leverage some of its properties. So in terms of low temperature capacity, you can see here carbon steel is minus 30 degrees Celsius. So when you are talking of cryogenic substances where you require temperatures to be far less than 30 degrees Celsius or 50 degrees Celsius, you may not be able to use carbon steel or low alloy steel. You need to go for other metals that can handle these very low temperatures. So with respect to pressure, you have Inconel, which can actually be up to 3,000 bar. They can be much higher than this, but it's just showing the minimum threshold of these metals in that range. So you see the different capacities. However, these stainless steels and nickel alloys are more expensive than carbon steel and the plastic kind of pipe. So there's a way to merge the benefits of different pipe types in order to achieve a certain objective by retrofitting them to be cost effective. So basically all of these pipe materials fall under the different industries. So if you are looking at the first industry, which was oil and gas, you have in most cases the pipes that are used in oil and gas are carbon steel grade B, X42, X52, X65, low alloy steel P11, P22, P91, and the likes. They are all listed here. Also, there are certain pipes that are modifications of these basic pipes. For example, you have SCR. SCR is steel catenary riser. So it's a kind of metal that is used for risers, where these metals are bent into certain curves in order to mimic the desires for pipes to bend when they are under heavy load within a fluid. So for power industry, you have grade carbon steel, grade B and C, low alloy steel, as well as stainless steel. So for the drinks and beverage, you have stainless steel and food grade plastic, then stainless steel um, and food grade plastic again for the food industry. So we move on, we have the chemical industry. And because you have chemicals, you can't be using carbon steel because of the high requirement of resistance to corrosion. You can see here stainless steel, Teflon line carbon steel, which is for cost efficiency, then nickel alloys. Then for the water treatment industry, you have carbon steel, PVC, HDPE. Lastly, for your HVAC piping system, carbon steel is used, stainless steel, HDPE, PVC, copper as well as PX are used for these industries. So these are a list of the different most likely pipes and grades that will be used for these different industries. So this is an overview that can give someone a mental picture of what is required in different industries. So remember to like this video as well as subscribe to this channel. On the website, I've left a link below showing the different kinds of fluid and their properties in these 7 different industries. For example, if one is designing a facility, you need to know the temperature of a fluid in each of the processing units. On that post in the website, you can see there the different temperature ranges for the different fluids for these different industries. Thank you for watching this video. Remember again to like this video as well as subscribe to the channel. This is Catchment of Resources, where we create for better living.